Welcome guys to today's tutorial. Today we'll be looking at testing a point on a straight line. Okay, so some questions we might be given, such as this. Does the point 3, 4 lie on the line y equals, let's say, 2x minus 2? Now, a lot of these questions, we could draw a table of values, draw up even a graph itself, and have a look to see whether or not 3, 4 lies on the line. But it's a really quick way of doing this, and it's quite straightforward. We know with all coordinates, the coordinates are always in the form of x first, and then the y coordinate. And if you look at our equation, all equations of straight lines have an x and a y in it. And if a point actually does lie on any particular line, when I put the y value into the equation and the x value into the equation, they should equal. The left-hand side should equal the right-hand side. If it doesn't lie on the actual straight line, then they won't be equal. So what we basically have to test is, if we substitute, in this case, x equals 3 and y equals 4, into that equation, if it equals and it makes the statement true, then yes, it does lie on the line. But if it's false, if it doesn't equal each other, then the point doesn't lie on the line. So let's go and substitute these values. So again, what I'm going to do, I'm just going to rewrite that formula there underneath. So y equals 2x minus 2, and underneath I'm going to put in our y value of 4 equals, now we've got 2x, so what does that mean? Well, we know if we separate the 2 and the x, in between them there's actually a times holding them together. So it's 2 times whatever my x value is. In this case, our x value is 3. And then the rest of it says subtract 2. Okay. So you can see in the green there, I've put my coordinates x and y. So let's go ahead now and see if the left-hand side is going to equal the right-hand side. Well, on the left-hand side, we've just got 4. On the right-hand side, we've got 2 times 3, which is 6. 6 take away 2 equals 4. Okay, so is that statement true? Does 4 equal 4? Well, yes, obviously it does. So it is true. I'm going to put my little therefore sign. Those 3 dots mean therefore. I can therefore, yes, the point 3, 4 does lie on the line y equals 2x minus 2. Okay, so we're going to look at the second example now. I'm going to look at the second example. Example 2. Does the point 3, 6 lie on the line? This time I'm going to do x plus y equals 4. Now, this isn't in the same format as last time. Last time it was y equals, but it doesn't actually matter. All we need to know is where is my x value, where is my y value, and then make sure the left-hand side equals the right-hand side. Again, basically what we're saying, does the left-hand side equal the right-hand side? That's basically the question that we're answering. So, like last time, we're going to look at our x and y coordinate. Well, you can see clearly here, remembering that our x comes first. Our x coordinate is the 3, so I'm going to put the 3 in there, plus, well, my y coordinate is the 6, and the rule says equals 4. Remember, that just comes from the rule that we're given in the actual question. So then I want to simplify. Well, we can do 3 plus 6. 3 plus 6 equals 9, equals sign, and 4. Okay, so now we ask ourselves the question, does the left-hand side equal the right-hand side? Well, does 9 equal 4? Well, obviously no. 9 does not equal 4. The only way that can be correct is 9 equals 9 or 4 equals 4, but they can't equal each other. So what I'm going to do, I'm going to put a line through that. Now that means not equal to. Okay, if you're not sure, I was right underneath, that means not equal to. So then I can make my final statement, because obviously that's false. You don't need to write false, okay, but I'm going to write therefore no. Because the left hand and the right hand side aren't equal, because that equation doesn't balance properly, it means that the 0.36 does not lie on the line. Okay, and that's it. So again, guys, just make sure you substitute your x and y value into the given equation. Does the left hand side equal the right hand side? And if it does, okay, then you're sorted and it lies on the on the actual line. If it's false and it doesn't equal, then it means the point does not lie on the line. Okay, hope you found this of some sort of advantage. Any more questions, please let me know.